Alright crew, we're going to do some example problems on the wave. Really though, legit name, polynomial inequalities. So, one of the main questions that I get from you guys is, where do I start? Do I start on the top or do I start on the bottom? We all know that we start at the right always for this particular kind of problem, but I hope to answer this popular question. And I have to tell you that it all depends on how the problem is being presented to you. So let's say these are the 3 problems that we're going to be working out in this video. How can you tell whether you start at the top or the bottom? Well, it depends. If the problem is being given to you already factored, then what you look at is the sign. You look at all of the signs in front of your x's. Why? Because if you FOILed this out, you want to see if any of these polynomials would end up with a leading coefficient that is positive or negative. Here, if you FOIL this, in fact, you have 2 of these, right, because of the square. But if you FOIL these guys, you'd see you would end up with an x cubed, a 2x cubed at one point, but it would be positive, right? So here, you know you're going to start at the top. Here, if you look at these, it does not matter that these x's are reversed. What you look at is, there is a negative sign in front of one of these. So if I FOILed this, I would get a negative x squared. Well, if I put that in standard form, kind of like this, that would tell me that my leading coefficient was negative, therefore I start at the bottom. Now, what's nice about them already in standard form is all you really have to look at is, hey, the sign in front of my leading coefficient is positive, so I'm going to start at the top. Excuse me. Pardon me, crew. I have a cold today, so my voice is also kind of nice and deep. Okay, so let's work out these 3 problems. Hopefully I now have a little bit of a clear understanding of where to start. So I'm going to start with the first one. This one is already factored for me, so again, I know that I'm going to start at the top. But let's actually just figure out what my roots would be. So here, my root, if I set this factor equal to 0, would be 5, right? And you are probably very good in realizing that since the power is squared on this, that means that this answer happens twice. In other words, this is a double root. Now, if I look at the 0 for this factor, things become a little bit more interesting in that when I solve for x, I actually get a fraction. Now, again, I don't care that your graphs are like perfectly spaced or anything like that. So if you just put -3/2 and 5 on here, then I'm good. Okay. Now, we had talked about how, because the signs in front of all of these x's, when they FOIL out, when they factor out, they are going to end up giving me a positive leading coefficient. I'm going to start in top. And I always start at the right, just to reiterate, for these wave problems. Now, I go through and I try to meet my first dot. This dot is a double root. That means you bounce on it and you come back down almost as if these were magnets. Now, this guy is not a double root, so you're able to go just straight through. Now, this graph is what I was expecting. I ended up having 3 solutions, 1, 2, 3, which means I'm expecting this sort of John Travolta kind of wave, right? Where the ends go in opposite directions. So, now let's look at what kind of circles I'm going to use. This is a closed inequality, right? These guys mean closed dot. These guys mean open dot. This was closed, so I'm going to go ahead and include those solutions, and that's a very important word. Those are included in the x-axis, right? So now I look, this guy is a less than, and I know that less than means I shade below, and greater than means I shade above. So I'm going to go ahead and shade everything that is all the pockets I've created that are below the x-axis, that are between my graph and the x-axis. Well, this becomes the only piece that is shaded. However, this problem is sneaky because it wasn't just asking for less than, it was also asking for equal to. So this is a strange problem in that you're going to have to include that 5 since it was shaded in. If it had been an open circle, well, you just wouldn't have cared about it. It was never included to begin with. But you have to include that dot. It was shaded in on the x-axis. Alright, so here's your clean graph. Remember, your test is going to ask for graph, and then it's going to ask for like set notation, and then it'll ask for interval notation. And so for your set notation, you're going to say that it's all of the x's that are less than or equal to -3/2. Every time you join inequalities, you use the word or, and then flat out, x is just 5, right? Either that or that. Make sure that you're using words in your set notation, and in interval notation you use the symbol for union. So here I'm going to say that I'm coming in from the left, so -infinity to -3/2. Here it's a closed circle, so I'm going to have to use a bracket. Then union with this next chunk, well, this is weird. We're just going to go ahead and put that number there. It only includes that number. So a little bit of a review. Remember, these guys are used for closed circles. All of these mean the same thing. These guys are used for open circles, and they're inequalities that look like that. Okay, so that's one problem for the wave that's also kind of strange. I wanted to do one that starts with the bottom, and this one is a little bit more simple because it's a quadratic. Again, if you distributed this guy, you would see that you would have a -x², and that's why I know that I start at the bottom. Okay, my roots here, if I set this factor equal to 0, would be, let's see, move the 3 over, so -3, and then here, if I move my x over to the right side, I get 5. I have 2 roots, so I'm expecting something that, like, points in the same direction, right? No matter how big the power gets, if it's even, I point in the same direction. Okay, so here I'm going to draw dots at 3 and 5. These are open, and I tell myself, well, were there any negative signs in front at the beginning? Yes, I'm going to start at the bottom, always start at the right, go through these dots. This is not a double root, that is not a double root. I'm okay not bouncing. And finally I shade in. Well, this tells me it's greater than, so it's telling me everything greater than 0. In other words, everything positive, everything above the x-axis. So I'm going to shade where my graph is above the x-axis. And so, again, you're asked for 3 answers on your test. Your clean graph, which is worth quite a bit of points. Then your set notation, which this time you're going to be a little bit efficient like this and say that -3 is less than x, which is less than 5. So we're describing this chunk. And finally, your interval notation, you're going to say you come in from -3 and you go to 5. Well, that wasn't so bad. Second example problem. Now, this wouldn't be complete without some perfect squares, because y'all know how much I like those. So don't freak out. Again, this is one of those like special trinomials that you should know how to factor, where x to the 4th, x squared, and constant are going to factor just like your usual little x method. And that actually works for anything where it's degree, half that degree, and then a constant. It actually works for everything. Now, here, you have to multiply to 1 and then add to -2. And so, you see that it's just x, minus 1 for both of these. But the weird thing about this one is, since you had to the 4th power, you have to go ahead and square these x's. Now you notice that you have my favorite thing, which is a difference of squares. And not only that, you have the same difference of squares twice. So I gave you a very special situation where you have x is equal to plus or minus 1 and x is equal to plus or minus 1. Well, that means that x is 1 double root and x is minus 1 double root. So this is interesting. This means I have 4 of them, right? I'm going to go over here. I'm going to draw my -1 and my 1. My dot is filled in. And this is telling me, again, remember to look at leading coefficient. This is telling me, because my coefficient is positive at the beginning, that I'm going to start at the top. So I'm going to start at the top. This guy's a double root, so I bounce. Come back down. He's a double root, so I bounce. Okay. So again, check every time that you do your wave graph that you got exactly what you were expecting. So since this was an even number of solutions, I did expect something to be pointing the same direction on both ends, right? Okay, so let's actually fill in. This says that I want everything less than or equal to. Well, this was kind of a trick question because there's no pockets that are below the x-axis, right? They're all above. They're all positive. So your clean graph would be just that -1 and 1. So this is a nice kind of special problem. Now here, for your set notation, well, what would you do? You would flat out say it's either -1 or 1. For your interval notation, actually no interval notation exists because there is no, like, shaded in no interval to begin with, so no interval notation. Now, if you wanted to be consistent and you gave me this because of how we forced interval notation before, whenever we had just one dot, it looked like this. I'm not gonna count off, so I'll take either or if you just tell me none, or if you tell me this. Those were the 3 problems, actually, that I wanted to do with you. They're all kind of strange. So, good luck. I think if you can do these, you can tackle the test fairly easily.